Assalamualaikum dan salam sejahtera. Saya ucapkan kepada Dr. Siti Fahana yang akan menonton video kami sebentar nanti. So before we begin, I would like to introduce our group. So our group consists of 5 people. We are from HL3 and the group members are Noor, Isma, Danial, Noor, Adriana, Noor, Liyana, Noor, Syafiqah, and also myself, Noor, Qhalisa. And for today, we'll be doing a group presentation regarding the FAD1007 assignment, question number 7, which is about ethylene glycol. So without further ado, let's go straight into the video. Alright, so for today's video, we'll be going over 4 major components. We'll be going over the introduction regarding the ethylene glycol and also the role of ethylene glycol in the automotive industry before going over the organic compound of it, as well as the calculation for the boiling and freezing point. So, sit back, relax, and enjoy the video.
Ethylene glycol. Ethylene glycol is a clear, viscous liquid primarily used in industrial manufacturing application and is an ingredient in products like automotive, antifreeze, and coolant. Ethylene glycol is produced by reacting the chemical compound, which is ethylene oxide, with water. The primary use of ethylene glycol is for polyethylene terephthalate (PET) plastic resin used to make beverage containers for soda, water, and juice, and also polyester fiber for clothes, carpet, and pillow. Ethylene glycol has a variety of other industrial uses, including, first, the manufacturing of fiberglass used to make products such as jet skis, bathtubs, and bowling balls. Second, the manufacturing of ink for ballpoint pen and other inks. It helps increase ink viscosity and make it less likely to evaporate. And the last one is heat transfer fluid, such as industrial coolants for gases, compressor, heating, ventilating, air conditioning system, and ice skating rinks. It gives industrial coolant properties that help them blow through cooling system while withstanding extreme hot and cold temperatures.
The main question we're about to unravel today as to why ethylene glycol is used as an antifreeze instead of ethanol. Alright, so it is true that ethanol is an antifreeze due to its low freezing point, which is around negative 114 Celsius, which makes it a very good property to make it into an antifreeze, but only in laboratory condition. And you may be wondering why. Okay, let me explain to you. It's actually due to the composition that we have in these two different types of antifreeze. Ethanol is considered as an RV antifreeze, whereas ethylene glycol is considered as a automobile antifreeze. And this is actually due to the composition that ethylene glycol has. So in automobile antifreeze, they have 90% of the glycol and only 10% for the additives. So for the glycol, it's actually the carbohydrate responsible for the primary function of antifreeze protection. And for the additives, they are only added in there to aid with the corrosion prevention as well as the lubrication of the system. So this is why the composition of the additives must be adjusted precisely to meet the requirements of the vehicle. So that is why there are various materials that are mixed in the rubbing hoses and also the gasket by manufacturers. So what happens if you add the wrong antifreeze in your car? It can cause serious damage because it can cause your cooling hose as well as the cylinder head gasket to corrode. And this can cause a total breakdown of your engine. So it's very, very important to choose the correct antifreeze for your car.
So Assalamualaikum and hi, so I'm going to continue this presentation. Okay, ethanol has only one polar OH group, meanwhile ethylene glycol has two polar OH group. So we all know that when ethylene glycol have two polar OH group, automatically it has a stronger intermolecular forces than ethanol. Since ethylene glycol have stronger intermolecular forces, therefore its boiling point and also freezing point is very strong, is higher than ethanol. That is why when ethanol is added with water, its freezing point will reach near 0 degrees Celsius. But ethylene glycol, when it is added with water, its freezing point becomes lower than initial. Thus, ethylene glycol can withstand the winter season compared to ethanol due to its lower freezing point. So we can conclude that for high liquid temperature range, ethylene glycol has temperature range between negative 51 degrees Celsius to 198 degrees Celsius, while ethanol has negative 110 degrees Celsius to 78 degrees Celsius. Ethylene glycol should neither freeze in water nor boil too easily. Okay, for non-corrosive, ethylene glycol also typically contain an anti-corrosive additive to prevent pure water from corroding coolant passages in the engine block, cylinder head, water pump and radiator. Meanwhile, ethanol is corrosive and damages the car's part. For non-flammable, ethylene glycol is way safer than ethanol. Ethanol is more flammable compared to ethylene glycol. Therefore, if there is leaks in coolant, it is easier to catch fire. That's all for me. Now, I will pass this presentation to somebody else.
Next, usage of antifreeze in summer and winter. Basically, for summer, as weather becomes so hot, antifreeze helps to ensure the liquid in our radiator doesn't boil over or evaporate easily by increasing its boiling point. While for winter, as weather becomes so cool, antifreeze helps to ensure the liquid in the radiator doesn't easily freeze by lowering its freezing point. Thus, in doing so, it protects engine from damage year-round.
So now, let me talk about the role of ethylene glycol as an antifreeze in automotive. So, ethylene glycol is known as 18-1,2-diol. First, ethylene glycol contains polar OH groups. They are polar because oxygen is a lot more electronegative than hydrogen. So, it tends to polarize the electron pair in the OH bond to acids. That in turn causes the oxygen to carry a partial negative charge and hydrogen a partial positive charge. Because of the opposite charge attract each other, this means that ethylene glycol molecules are attracted to each other, making it harder to pull them apart, and this in turn makes its boiling point higher than that of hydrogen carbons of similar mass. So, pure water has a boiling point of 212 degree Fahrenheit, which is 100 degrees Celsius, and a freezing point of 32 degree Fahrenheit, which is 0 degrees Celsius. However, when we create a 50-50 mixture using water and ethylene glycol, the boiling point rises to 223 degree Fahrenheit, which is 106 degrees Celsius, and the freezing point lowers to negative 35 degree Fahrenheit, which is negative 37 degrees Celsius. So next, when we take it one step further, creating a 30-70 mixture of water and ethylene glycol, the boiling point rises to 235 degree Fahrenheit and 113 degrees Celsius, and the freezing point lowers to negative 67 degree Fahrenheit, which is negative 55 degrees Celsius. So, when water is freezing, its molecules will be expanded and crystallized as the temperature of the liquid decreases, the molecule making it up to move more slowly and experience an attractive force between each other. In pure water, at 32 degree Fahrenheit, which is 0 degrees Celsius, this attractive force is powerful enough to arrange the water molecule in a regular crystal pattern, greatly increase their mobility and causing the formation of ice. When ethylene glycol was added to the pure water, the presence of polar OH group in the ethylene glycol will make the water molecules harder to join together. Thus, more heat energy needed to be released to the surrounding to make the molecules join together and crystallize. This will make the freezing point of the mixture decrease.
More about the ethylene glycol. First of all, is the molecular formula of this molecule is C2HCO2, and the structural formula is already shown in these slides. And the last one is the IUPAC name is 18-1,2-diol. After that, we're going to proceed to the calculation of freezing point and boiling point of ethylene glycol. First part is the freezing point. In order to solve this problem, we have to use this formula, which is Kf times M equals to delta Tf equals to Tf naught minus Tf. So first, we have to find the number of mole of the ethylene glycol by using the formula of mass divided by the molar mass. And we got the answer is 10.483 mole. After that, we have to find the molarity, which is small m, by using the formula mole of the ethylene glycol divided by the mass of the water. And we got the answer is 4.185 mole per kg. After that, we can finally use the formula, which is Kf times m equals to delta Tf, and we got the delta Tf is 7.7841 degrees Celsius. After that, we can use the other part of the formula, which is the Tf. The delta Tf equals to Tf naught minus Tf, and there is a note that the delta Tf, which is actually the freezing point of the pure water, is 0 degrees Celsius. Therefore, we can get the final freezing point, which is negative 7.7841 degrees Celsius. After that, we're going to proceed to the boiling point. We can find the boiling point of the ethylene glycol by using this formula, which is Kb times M equals to delta Tb equals to Tb minus Tb naught. So for the first one, we can directly calculate the delta Tb since we already have the molarity, because we already calculated the molarity before, and we got the delta Tb equals to 5.41 degrees Celsius. The next one is we're going to calculate the Tb, and we already know that the boiling point of the pure water is 100 degrees Celsius, and finally we got the final answer, which is the final boiling point of the ethylene glycol is 105.45 degrees Celsius. So that's all for us. Thank you.